Hello and welcome to an introduction to A-Level Chemistry. My name is Mr. Allen and I'm Head of Science as well as Lead Teacher of Chemistry at Waldegrave. This short video should give you an idea of the course and hopefully answer some of the questions you may have about pursuing chemistry beyond GCSE. So the first question you're probably asking yourself is, having only got 3 choices at A-Level, why choose chemistry? So why are we studying chemistry? Well, the subject of chemistry is beneficial to, and in some cases mandatory for, future ambitions. Chemistry gives you a platform to move on to a multitude of careers. Some of those careers are more obvious than others. Things like medicine and pharmacy, dentistry, veterinary medicine or veterinary science. However, chemistry can be useful in environmental science. It can be beneficial for anybody looking to study law, especially if you're looking to branch into things like policy making, where an expertise background knowledge of science is required, or becoming a patent lawyer. This graphic by the University of Galway summarises quite nicely the future areas of study if chemistry is taken at A-Level. Now, if you take it at A-Level, that then allows you to move on to a chemistry degree, where the vast majority of these areas are branching from. So you've got the idea of food and agriculture, you've got the pharmaceutical industry as mentioned, or if you are in love with the subject so much, you can stay in academia looking at research, teaching at a university, or looking at becoming technical support associated with particular areas of chemistry. Now, other than the future careers specific to science, studying chemistry can provide opportunities to build transferable skills. Now, these transferable skills can be utilised in any given job. Things like logic and problem solving. Now, if you're looking for a career in something like finance or marketing or business, problem solving is going to be one of the massive tools, one of the best skills that you can have in order to succeed in that particular area. A lot of you will have watched The Apprentice, and it's the idea of being able to problem solve in that given environment. That particular skill can be attained by studying chemistry. You also have the idea of number or data manipulation, interpreting and analysing data, as well as building your confidence to clearly and effectively communicate with appropriate reasoning. Now, having studied chemistry at Waldegrave, many of our students have moved on to further education, either studying chemistry or subjects where the content and transferable skills have helped them greatly. So I've got 7 universities on the screen at the moment. These are 7 universities that many of our students have gone to in the past couple of years. So if we just take a tour around them, having studied chemistry at A-Level, we've had some students go on to the University of Warwick, the University of Nottingham, as well as the universities of Birmingham, Bristol and Edinburgh University to study chemistry at degree level. They found that taking their A-Level course ensured that they were well prepared for the complex content that was being studied from the off. We've also had students go on to study medicine at Manchester University, as well as Newcastle and Southampton. As well as students heading off to the universities mentioned previously to study chemistry and medicine, we've also had students go on to do dentistry, as well as students heading to London universities, places like UCL or Imperial, as well as King's College London, pursuing studies in biochemistry and engineering. So you can see from just taking the chemistry A-Level, they've been able to branch out into areas of STEM that they've had a particular interest in. Now, that's just giving you some ideas of where you can go with a chemistry A-Level. But if we take it back a step and move back into yourself taking chemistry A-Level, we're going to go through the idea of what you will study and some key information. So what we study is Chemistry A from the exam board OCR. Now, at GCSE, the vast majority of students study AQA. That gives you great foundations to move on to A-Level. The idea that we've changed exam board is part and parcel. It is nothing to worry about. When you move into A-Level study, there are 2 years. In the first year, you study modules 2, 3 and 4. Now, modules 2 is a foundation in chemistry. You look at studying subjects like atoms, elements, compounds, and formula. You also look at studying the amount of substances, so you're again reintroduced to the idea of the mole, as well as looking at electrons and bonding, shapes of molecules, and acids and redox. After we have completed Module 2, you then split into two pathways. One teacher will teach you one pathway, and the second teacher will teach you the other. Module 3 looks at the periodic table and energy, so you'll look at topics like reactivity trends, the idea of repeating patterns across the periodic table, as well as things like enthalpy, rates of reaction, and that lovely topic of equilibrium. In Module 4, you start to build the basics of organic chemistry. Now, having looked at the GCSE syllabus, you will have already seen that core organic chemistry is part of the GCSE. So you're essentially building on the foundations that you've set at that particular time. You look at different families of organic compounds, primarily things like alkanes, alkenes, alcohols, and haloalkanes. Once you move into Modules 5 and Module 6, that's when you'll be entering Year 2 of the A-level course. Now, Module 3 links quite nicely with Module 5. You start to expand upon ideas that you looked at in Module 3, and you start to look at other aspects of them. So in Module 5, Physical Chemistry and Transition Elements, you revisit the idea of rates of reaction and equilibrium as two core topics, as well as acids, bases, and pH, followed by topics like redox, electrochemical cells, and finishing off with transition elements. In Module 6, you're again building on the solid foundations that you've made in Module 4 to enter a more complex organic chemistry. You're looking at the idea of synthesis and analytical techniques to identify unknown carbon-based molecules. Now, Module 5 and Module 6 present a great challenge, a big step up between Module 3 and Module 4. Most people say there's a big jump between GCSE and A-level, but most chemists find that there's a bigger jump between Year 1 and Year 2 versus the jump between GCSE and Year 1. Now, alongside the modules that you will study, there is also the idea of a Module 1. Now, Module 1 is the development of your practical skills. It's a practical endorsement that is studied across both years, and I'll come to that in a few slides' time. Now, I've identified each module comprises of different topics. Each of those topics that I named would have an assessment after them. Now, there may be scope for a second assessment in a particular topic that you may have found difficult. The final exam is studied after the end of Year 2, so we don't do an exam that is externally assessed after Year 1. We have our own in-house mock exams. At the end of Year 2, you will complete 3 papers. The total marks for all of those papers is 270. Now, if we go to have a look at the breakdown of those particular papers, the papers themselves, paper 1 is looking at your periodic table, elements and physical chemistry. So that was the idea of Module 3 moving into Module 5. The paper itself is 100 marks and the duration is 2 hours 15. Now, the paper itself has 2 sections. Section A is multiple choice. There are 15 multiple choice questions, followed by 85 marks of extended writing. Now, the vast majority of questions on this particular paper are from Module 5, and there is a significant amount of maths content that is studied in this particular paper. Because of the number of marks it's out of, the weighting for this particular paper is greater than 33%. Paper 2 is synthesis and analytical techniques. So again, it's looking at the Module 4 into Module 6. It's looking at the organic side of the course. Again, the paper is 100 marks and has 2 sections. Section A being your 15 multiple choice questions, followed by, often, equations or mechanisms in Section B. Now again, the paper is 2 hours 15 with a weighting of 37% because of the total number of marks available for it. Paper 3 is where the challenge really hits. This paper, slightly less marks than the other 2, is unified. Now this means that there are every single possible topic can be asked in this particular paper. So you're assessed on your ability to recall content from modules 2 to 6, as well as apply your practical techniques that you would have done in your practical endorsement. Now, the practical endorsement, as I've mentioned before, which essentially is Module 1, is not examined or is not graded by the exam board, but is marked internally, and you will be graded as a pass or a fail. Now, some outlines in terms of the course that you will study. There are 9 lessons per fortnight. That will be a 5-4 split, meaning that of the 2 teachers that you have, one of your teachers will teach 5 lessons and the other teacher will teach 4. The timetabled work periods on your 6th form timetable will allow for independent study for all of your subjects at A level. So that means that you can dedicate time for study around chemistry. That could involve completing revision, revising for assessments that are cropping up, as well as homework or tasks that have been set by your teacher. In chemistry, we do have study sessions that will be available at lunchtime or after school. These sessions may in fact become compulsory if you are finding the course particularly challenging. Now, if I go back and I talk about these PAGs, these practical assessed groups, this is the idea of the development of your practical skills alongside your A-level. So the content from these practicals, the skills that you develop, which could be transferable skills, things like manual dexterity or data manipulation, they will be assessed by your teacher, so it's not coursework. However, the content of these practical skills, these practicals themselves, will be assessed in your exams. So that could be the method, that could be the science behind the practical. The PAGs, like I said before, are given a pass or a fail and will show up on your final results for your A-level. Now, the one thing to clarify is that failing these practical endorsements will not affect your A-level grade, but there are some universities that may make passing it a condition of your offer. So it is important that you give your full commitment, that you're present for all of these practicals, and you ensure that they are successfully completed and handed in, all feedback is responded to, and they are filed accordingly. In this development of the practical skills, there are 12 subsections, which means that there are a minimum of 12 practicals that have to be completed to ensure that you have competency. One practical from each of these 12 subsections will be completed. However, there are sometimes an opportunity to do more than one practical from each of these subsections. That will ensure that you've got multiple opportunities to develop the skills that are expected from you from the exam board. Now, if you're thinking about, I really want to study chemistry, how am I meant to prepare? The very first thing that you can do is you can start to revisit your GCSE notes. All of the content that you studied at GCSE is applicable at A-level. Some people always talk about how A-level chemistry is completely different from that at GCSE. There are at times where we have to go back and re-establish new foundations. However, we are building upon an oversimplified model that will really help you understand this incremental challenge associated with the course. If you're still looking for more to do, what you can do is you can purchase the A-level textbook that we are using for Year 1 and Year 2. It is Chemistry A from OCR. The image shows the front cover of the book. Now, you can get it as either a Year 1 or Year 2 textbook, or you can get the Year 1 and Year 2 textbooks combined. If you're looking for something like a bridging work or an opportunity to read up on post-GCSE pre-A-level, the bottom book, which is a Head Start to A-level Chemistry, is a book that you may find particularly useful. What else will I need in order to study chemistry? What you will need is you'll need a lever arch folder with 5 file dividers. They will be the 5 dividers for the 5 modules for your written work. Within that folder, what will you house? You will have your own class notes. You will have any worksheets that are given out. You will have tests or assessments, and you will have any feedback that you will have done as a directed task after an assessment. Like I said, you would also need your A-level textbook. It is also encouraged that you get a lab coat and some safety glasses. Now, we do have safety glasses in school. However, most people often complain that they are scratched and hard to see through. So if you have your own safety glasses, then you can take care of them yourself. If you do get your own lab coat and safety glasses, which is encouraged, please make sure you put your name on the lab coat and safety glasses, as these have a tendency to go missing. You'll also need a ring binder, so that's not a lever arch file, that is a ring binder for your PAGs with 12 dividers. That will split it up into the 12 subsections for this particular activity. You will need exercise books for your lessons. That will ensure that all of your written classwork and tasks within the classes is all in the same place. Stationery, pens, pencils, ruler and a calculator. A calculator is super important at A level as there is a significant amount of maths content. What you could also do is you could print yourself an OCR datasheet. This can be found on the website, or if you do want to find one, you're more than welcome to come and ask myself. This will ensure that you get you will familiarise yourself with the style of periodic table that we use and any other data that you may find within that particular datasheet. I hope I've been able to give you a brief overview of what chemistry is like at A level and hopefully answered some of your questions that you may have had, whether that is future career pathways or what it will be like to actually study the subject itself. If you have any further questions or you are really keen to understand more about chemistry A level, then please do not hesitate to get in contact with me. You can either find me in school, or if you are an external, then you're more than welcome to email the school's sixth form and they will put you in contact with me. I hope to see you in the next stage of your chemistry journey. I wish you all of the very best.